Ladies and gentlemen of Precalculus, welcome to Precalculus class today. Today what we're doing is building upon what we talked about yesterday somewhat in this section 2.3. And in exercise 33 through 36, we're going to find the zeros of a function algebraically. So what are ways we could find the zeros of this function here?
Make it equal 0.
Find the square.
Go. What did you say, Angel?
Make it equal 0.
Yeah, let's go ahead. Let's find set this equal to 0, because, and I'm going to go ahead and talk about. So the first step I would do is what Angel suggested, is to set this equal to 0. And what are synonyms for zeros? What's
Roots.
What roots is also synonym? Very good. What else? X-intercepts is also a synonym. Any other synonyms? Now it's not exactly a synonym. What's another word that's almost like a synonym but not quite? Starts with an S. Well, what it is, once you set this equal to 0, another word that goes along with these is called a solution. Because what happens is your solutions are going to be when you set a function equal to 0. Okay? And so these will be solutions if the function is equal to 0. And what are the techniques we could use to solve this function or any function? Or how can we solve this?
Completing the square.
Completing the square? Okay, we could complete the square. Okay, that's a technique. So I'll put down 1, complete square. Any other techniques we might use first before? And that would be an algebraic solution, yes.
The x thing.
Pardon me?
The x. Or like
Oh, you mean factoring?
yeah.
Yeah, factoring. And factoring is going to be your easiest way to do it, usually, if you can do it. So these will be two techniques. Also, you have quadratic formula. And all three of these would be algebraic means of solving. And then you have also the solve by graphing, which is not going to be algebraic, but it's going to be related. And then another way is called the square root method. Square root method is kind of limited because it only works if you don't have an x term in the middle. Okay? Those are the 5 major methods of solving, and this one right here is going to be your go-to most of the time if you can do it pretty easily. And when you see something like this, would you assume that you could do that? Yeah, I'd assume it, right? So what is this going to be over here?
One is going to be negative.
Yeah, one will be negative and one's positive. We know that because that's how we could get that. So what is this going to be here?
X minus 2 and x plus 4.
So Kayla gets x minus 2 and x plus 4. Is she right about that?
Yeah.
Yes.
Yeah, she's right. So now we can go ahead and use our zero factor property. So what is x equal to?
2.
2.
Negative 4.
X is equal to negative 4. So these are the zeros found algebraically. All right, now when we get to 35 and 34 and 35, you're talking about a level of complexity beyond this where you don't have x squared to the first power. So I want you to do 34, and I'm going to call on somebody.
Can you go back, please? Thank you.
I want to try completing the square on that one too, because that'd be a cool way to find it. I think you're going to get
Okay.
you'll get negative 1 plus or minus 3 is what you're going to get. But we'll look at that if we have time. Okay, 34. You're working on that one?
Yes.
I'll call on somebody here in another 2 minutes. Okay.
That's right.
I'm gonna call somebody here. It's gonna help us out with number 34 here. It's gonna be Hanover. All right, Hannah, what do you got?
X equals 2 and X equals negative 2 over 3.
So this one, Hannah, how did you solve this?
I made it equal to 0 and then separate, what is that word? I used like the X method.
Oh, she used X method, so 3x squared plus 4x minus 4. And so what you did is you found what the factors were.
Yeah, and it was 3x plus 2.
So what you had up here, you did, what goes up here?
Negative 12.
-12, and then
4.
4, and then
2 and negative 6.
2 and -6. Yeah. Well, hang on a second.
What did you do, 2 and 6?
Should be
6 and negative.
6 and -2,
Oh. Yeah.
right? Okay, let's go ahead. So now we're dividing by 3, right?
Yeah.
So we have 2, and so we have x plus 2, right? And then we're going to have, for this other one, we're going to have, you have x minus 2/3, and bottoms up, that's going to be 3x minus 2. And then if we set these equal to 0,
It's negative 2 and positive 2 over 3. I'm just gonna mix it up.
so, yeah, but that's the easiest thing in the world to get mixed up. So we got x equals -2, x equals 2/3. Okay? Questions on that? Okay, good, still good work. Good strategy involved here. So did you get wrong over here, Hannah, in this deal?
Yeah.
Did you get it mixed up here? Okay, that's the easiest thing in the world to do. But good work nonetheless. All right? No hay preguntas? Okay, I'm going to call on somebody to do 35 here in a second. Which should be similar to 34, I believe. Okay, let's get another victim.
How would have the last one have been x plus 2, 3x minus 2? Because if you do x, if you do the table, then...
So Kenzie, Emily's going to be on deck on that, but Kenzie, you had a question? What was your question?
Never mind, I figured it out.
You figured it out? Okay. So you were Emily on this one?
I'm working on it.
She's not quite finished.
I think I got it.
Okay. What do you want me to write?
I did the x method.
So you want me to do an X method up here?
Yes. Negative 18 at the top.
So negative 18 goes here,
Negative 3.
negative 3 goes here,
And I got negative 6 and 3.
negative 6 and positive 3, you say?
And then divide both of those by 9. And then simplify those to 1/3. And then negative 2/3.
So then we have this, right?
Yes. And so x equals positive 2/3.
So X is equal to
Positive 2/3.
2/3.
And then negative 1/3.
X is equal to negative 1/3. Okay, does that look right? Okay, good. Anybody look on the, I see people with graphing calculators. The graphing calculator showing the same thing? All right, looks like good work to me. Are you getting so it's pretty easy? Like you can almost do this in your sleep? Yeah, should be. Takes a little practice. Okay, this one here, I want you to do that one. I'll call on somebody in another half a minute. Okay. So here we go. It's going to help us with number 36. It's going to be Emma Lee. All right, Emily, you ready to go on this one?
Still working it out.
Okay.
Being honest with you, I don't have to.
Okay. What was it that Angel told us to do? first thing he said when he did this? What did Angel tell us to do?
I don't know what you needed.
What did he say? When he said, we got back here and asked the question, how do we solve this? The first thing he said was what?
I wasn't here when I did that one. What did you do?
Okay. Oh, well, so, so the first thing is going to be this. This is what Angel said to do, right? Okay, what next? Should I call somebody else?
Mr. G, I know this one.
Okay, I'll call somebody else. Kayla.
Woo! Kayla! Huh?
Okay, you got 36.
Is the extra 25? No.
Yeah, but I want you to tell me how to solve it. You got x equals 25, is that an answer?
Yes.
Anything else?
No.
Well, that'll be one of our answers.
Why would it be negative 25? Zero.
Okay, look, it's going to be, I'll tell you why it's 25.
Negative 25 because
Look,
negative 25 times the 25 right there would make it positive, so it'd be plus.
yeah, so,
I got 0 and 25. I got 0 and negative 25.
okay, let's look at this. We're going to test Kayla's solution here. If we take 25 squared, right, minus 25 times 25, so 25 squared is 25 times 25, minus 25 times 25 equals 0. So this is a correct solution. Is that the only correct solution?
Yes.
X is equal to 0 also. Okay, now to me, the easiest way to do this is by factoring. And for this, you look at our common factor, which is x. So you have x times x minus 25. So here you have x is equal to 0, x is equal to 25. Okay, same thing.
I use the X method.
And you still got it right?
I use
Yeah.
the box,
And use the box method too?
but I got negative 25.
You got negative 20. Yeah, you should get it. Now, Kayla's right about this because if you use negative 25, what you'd have is you'd have negative 25 squared, which is 625, plus 625. So you get like 1250 instead of 0. So that's why it's not going to be negative 25. Okay? Now, what we're doing is we're kind of just starting here on 39 and 40 about kind of putting together things we've done the last few days. And so you look at it, you say state the degree and list the zeros of the polynomial function. So for number 39, what is our degree of this function here? Okay, let me start you out on this. What you do is you multiply all the x's together. So we got x times x squared. What's that going to be? X cubed. So what is our degree of this function? 3. Now it doesn't say this, but this is going to be a positive natured function or negative? Positive. Then it says list the zeros. And so what are the zeros of this function?
3 and 0.
So we have x is equal to 0 and x is equal to 3. And it says whether the graph, what is the multiplicity of each 0?
1, 2, 0, 3.
Multiplicity equals 1 and multiplicity of 3 equals 2. Okay, crosses or does not cross? At 0, do we cross or not cross? Crosses. And then at 3, do we cross or not cross? not cross. Why do we know it doesn't cross here? Not cross because we have multiplicity of 2. And so now, this one right here, are we going to start low, end high, start high, end low? So we're going to start low and end high, and we mark our zeros here at 0 and at 3. And what do we do next with this thing here? We start and we approach this 0 here at 0, right? Are we going to cross or not?
Yes.
We're going to cross. We come down here and we're going to get to 3. Are we going to cross or not?
No.
Not. And we're going to go like this. And so really that's going to be it for number 39. So I want you to do number 40, and I will choose somebody to do number 40 here in 3 minutes. Okay? Do you kind of see how what we're doing with this sort of puts together some of the things you've been doing the past few days? With the factoring, with the finding the zeros, with the multiplicity of zeros, and all this kind of stuff. Okay, let's get to our, we're down to few contestants left. And we know Will's not here today, so Will won't even count. Hey, Adam.
Atom bomb.
The atom bomb. We got the atom bomb. Okay, Adams. Help us out, Adam. We have, what is our degree of this guy here? 4, okay?
Negative.
And he says 4 and negative nature. Everybody agree with Adam thus far?
Yeah.
Okay, yeah, looks good. And we're going to find our zeros, right? What are the zeros we have here?
X equals 0.
X equals 0 and x equals 2. What is the multiplicity of each 0?
1.
Which one is 1?
Well, or 0.
This is 1, multiplicity equals 1. And what about this one?
1.
Okay, now here's a problem we have here, because our multiplicities should add up to our degree, right? And we're not seeing that, so probably one of these is not right. Which one do we need to change?
0.
0.
3.
So this one should be 3 here, is what you're saying? Okay, now next thing, crosses or does not cross?
Crosses.
So crosses. And down here, is this cross?
Yes.
Okay, crosses. Okay, now for graphing, are we going to start high, end high, start low, end low?
Start low, end low.
So we're going to start and end, right? And so we mark our x-intercepts here at 0 and at 2. So we're going to start down here. And you said we're going to cross? What does crossing with degree 3 look like with 3?
It hits and kind of...
Yeah, it hits kind of curls like this. And so we're going to continue going up and then come down. What's going to happen here?
Cross.
We're going to cross straight through. So it's going to look something like this. Did anybody graph that in the calculator? Did you see it that way?
Yeah.
That's what you saw? Okay, good. So anyway, that's some good work done on this one here. And if you see, and this is the last one you have on your sheet, but tomorrow we're going to go ahead and do a couple more that are similar to that and go on. We're going to leave it here today, all right? All right, thank you.